All right, Kens, we're on this part where we're writing what the variables in this equation mean. We have height over here. G is acceleration due to gravity. They give you feet per second and meters per second. Okay. T is time. This is the variable this is like my x variable. So I have time going on here. V naught. What does V naught stand for? The initial velocity. So I could be throwing this thing really hard, in which case it's going to travel really far and it's going to hit the ground sooner than if I just lob it, right? Okay? Or if I launch it out of a gun and it shoots it really fast, it's going to travel farther than it would if I would throw it, right? So that's what velocity represents as it comes out of the gun or as it comes out of my hand. What is its initial velocity? Anytime you see 0 on the end of it, they call it V naught. Has Mr. Muth taught you that? Naught, like K-N-O-T, right? V naught, and that's like V0. So at a time of 0, what is the initial? What's the velocity at zero? At 0 time, what's the velocity? What's the velocity to start with? Okay. What does S0 represent?
Initial height.
Initial height. Yeah. How high am I launching it from? Because if it's coming out of my hand's not on the ground probably, unless I'm bowling, right? In which case my bowling ball is doing a parabola. That's not a very good idea. But my hand, even if it's coming out of my hand, it's probably going to be like a couple feet in the air, right? Okay? So initial height. All right. Next, let's do this. A toy rocket shot straight upward from a launch pad 1 foot above ground. Okay, what's 1 foot above ground? S naught is 1 foot, okay, above ground. Has an initial speed of 64. That is V naught. Okay? Which one do I want to use? 9.8 or 32?
32.
Why?
Per second. Because the initial speed is already.
Yeah, 32 is in feet per second. That's what I want. Is everything else is in feet, so I'm going to use 32 instead for G. Writing model to represent, so I'm just filling in the blanks, right? S of T is equal to negative 1/2 times G, which we said was 32. T squared. What? Plus.
Well, we haven't got there
yet.
That's part of the equation. That's part of the equation.
On the end.
This goes on the end. Yep, you're fine.
Height.
V naught was 64, so plus 64T, and then plus my initial height was 1. So that's plugging everything in for the equation. I'm going to write in better. Let's go S of T equals negative 1/2 times 32 is negative 16T squared plus 64T plus 1. There we go. All right, now they have graphed this function. Hey, look, theirs matches ours. Great. They say determine the times at which the rocket is above 50.
So we're going to go.
So we want our height to be, we want this to be greater than or equal to 50. Or equal to or not equal to.
Wait, it's the other way, isn't it? No, wait, no.
This is my height, and I want that to be bigger than 50. So I want 50 to be small, and the other part to be big. Greater than or equal to or not? Just greater than. Okay. Negative 16T squared plus 64T plus 1.
Can't we just say from?
Can I subtract the 50 over? Let's do that.
Can we
Okay. 0. This is what I have.
Can we?
What?
Can we not just look at their graph where they give us the numbers?
They won't always give us the graph.
They won't give us the graph.
I know, but.
So we use that.
Okay. All right. How do I solve for T now?
We're going to do the
Quadratic formula.
Yeah, I'm going to guess they got 2.97 and 1.03, so they used the quadratic formula probably. I'm going to go down here.
Which is
Negative, I'm going to write it out. Negative B plus minus square root B squared minus 4AC all over 2A. Okay? Negative B will be negative 64 plus minus square root B squared minus, B squared, 64 squared. Minus 4 times A is negative 16. C is negative 49. All over 2 times.
Well, that guy's going to be negative.
He's going to be icky. Yeah, that part's going to be negative. Well, maybe not. 64 squared is going to be bigger than probably that stuff. Yeah? Because I thought that too. And I'm like, nope, because then we wouldn't get an answer and that wouldn't be right.
You're right.
Okay, so if we do this and we do this negative 64 plus all that junk, we probably get, I don't know, like 2.97.
Yeah, plus.
Okay, if we do the minus, we probably get 1.03 because I'm cheating, right? One answer is 2.97, one's 1.03. Okay? Now, this means that if I do this on a number line, whoop, I have 1.03 and I have 2.97.
Open circle, open circle.
Okay? Open circle, open circle. Okay, now let's test some points. What's a number that's on the left side of 1.03? 1 or
0.
0?
Because we have to.
You can test 1 if you want to. What's the number between 1.03 and 2.97?
2.
2. What's the number that's on the right side of 2.97?
3.
3. Let's test them. Okay, what are we plugging into, by the way?
Well, don't we have to know?
This thing, 0 less than negative 16 t squared plus 64t minus 49. We're plugging in 0 to begin with, right? We're plugging in 0 to begin with.
49.
So if 0 goes here and 0 goes here, it knocks those two things out, so I get negative 49.
And he is less.
Negative 49 is this true?
No.
Is 0 less than negative 49?
Nope.
No. Okay? If I plug 2 in, let me erase my stuff.
You want me to-
0 less than, if I put 2 here, 2 here, that would be
15.
4. This is negative 64 plus 128 minus 49. That is something.
15.
15. 0 less than 15. Is that true?
Yep.
You betcha. If I plug in 3, I don't know, you get a negative number. 0 less than whatever 3 is.
Oh shoot, why are we plugging in 0?
Because 0's over here. If I plug in 3, it's not going to work if I plug in 3. So that means that he is above 50 feet in the air between
0.103 seconds.
1.03 seconds to 2.97 seconds in flight, or if you do it like this, 1.03 to 2.97, that's interval notation. That is when he is above 50 feet in the air. So 3 seconds into flight, he is below the 50 height mark, right? 5 seconds, he's below the 50 height mark. He might be on the ground by then. I don't know. Okay? So as long as he's between 1.03 seconds to 2.97 seconds, he's above the 50 foot mark.
Concave.
Otherwise, he's doing one of those.
Down, right?
What?
Those two spots is a concavity.
The whole way through, he's concave down.
Josie.
From here to here, he's increasing. From here to here, he's decreasing. But the whole way through, he's concave down. Whatever. Okay, there you go. This is when he's above 50.
If my classes blur together, then
Woo!
then I know, like, oh, I just remember this part. Because we were doing velocity initial the same time we talked about velocity, or V naught in this class and in physics. So I'm like, oh, I remember this. And then, I don't know.
Right.
I
Putting
don't know.
pieces together. Like, it's,
I need to
that helps you
not.
remember it better.
I need to not. But
All right, there we go. Bye, Mackenzie.